All right, let me just get this started. All right, so thank you everyone for joining us today. We're going to be talking about a multi-node OpenStack deployment using packstack. So I'm going to step through a few slides here to introduce the topic. We're going to run a packstack install in the background, and we are going to talk a little bit about the architecture that we're heading for. And once everything's finished running, we are going to take a look at what got configured and how everything looks, what sort of post-install tasks are necessary, and actually boot up an instance and get things going. So here we go. So we are going to be setting up an environment that has 4 nodes in it. One is going to be a controller. One is going to be the network host, and we'll have 2 compute hosts. And I will talk in detail a little bit about what those are in just a moment. We're going to be deploying everything on top of CentOS 6.5 using RDO Havana, and we'll be using packstack for our deployment tool. I want to talk a little bit about packstack in a moment. It's a command line tool developed by Red Hat for deploying simple OpenStack clouds. It lets you do single or multi-node deployments, but it is targeted primarily at proof of concept or testing environments. It's not really designed for setting up your production OpenStack cloud. There are some things that it doesn't do that you'd get with a more enterprisey tool like Foreman or something. It's not a server provisioning tool, so you have to have your system set up in advance. And it doesn't set up any of the HA or load balancing or scalability options that you have with OpenStack. It should support pretty much any Red Hat variant, so actual RHEL, CentOS, Fedora, things like that. Probably Scientific Linux also. So I'm going to take a brief break from talking. We're just going to start up the packstack install in the background here. We're doing that because it does take a while to run, and I want that to finish while I am still talking so we don't have to stare at an empty screen. So let me switch here, hello, to another window. All right, and get this started. All right, there we go. I'm going to let that run and return to our slideshow. Hello again. There we go. All right, so while that's running, this is a high-level overview of what we're setting up with this environment. We've got our 4 nodes. We have 2 networks. One is going to be for communicating between the controller and the other services. We're going to call that the control of the API network. In this diagram, that's the blue one, 10.15.0.0/24. We're going to have a second network, which is going to be used to connect tenant networks to the network host. That's the 10.19.00/24 network there. We're setting up GRE tunneling for tenant network connectivity, so between each compute host and the network host will be a GRE tunnel connection. And we'll see the details of that in just a little bit. So neutron networking using the Open vSwitch plugin for, I see that some folks are reporting problems here on IRC. Let me just check. Hold on a second, just checking here to make sure that other people are able to see video and audio from this. Excellent. All right, so moving on. So Open vSwitch plugin for the actual network plumbing on the hosts, and GRE tunnels for realizing tenant networks. Now, in a production deployment, rather than using just the Open vSwitch plugins, you would probably be using a vendor plugin to connect OpenStack with your Cisco or Juniper devices or something, but we're using just Open vSwitch Linux support right now. So the controller is running everything that does not fit into the category of network or compute. We'll have the database server and the message broker. It'll have Keystone, which provides the identity service, Glance providing the image service, It has all of the controller side Nova services, the API, the scheduler, the conductor, and other things. And it has Cinder, our block storage service. The network host is running just the Neutron services. So it has the Neutron server, which is kind of the API component of that, and then all of the agents that implement various features. The DHCP agent sets up IP address distribution for each network that you create. The L3 agent is responsible for setting up the virtual routers. The Open vSwitch agent, which runs both here and on the compute host, sets up the actual plumbing, connecting all the bits and pieces together. And the metadata agent there is what allows your instances to ultimately have access to the Nova metadata service. And we'll look at that, I think, a little bit later on. The compute host is running just the Nova compute service and the Open vSwitch agent. This is the system on which we will actually be booting virtual instances. So this is the actual hypervisor here. And we're going to have two of these in the setup. So you want to sit down and install your environment using packstack. Let's talk about what you need to do to get started. Come back here, screen. There we go. So the first thing you want to do is set up SSH. For packstack to operate, it needs to be able to SSH into all of your servers as root. So from wherever you're running packstack, make sure that you're able to do that. That may take you a couple seconds to set up, but it's not bad. Then you want to install packstack itself from the RDO repositories. Now, I should have a link here to our quick start documentation. I don't right now, but it's really easy to find. You can see that in the first line here. And installing the Openstack packstack package. That provides the packstack command itself. I'm going to say packstack a lot during this presentation. It's going to stop sounding like a word. And that provides the Puppet modules and whatnot that packstack uses to operate. Now we need to tell packstack what to do. There are a couple ways of doing that. You can specify a bunch of parameters on the command line, and that will cause packstack to go off and do what you've told it to do. And it will generate an answers file for you after the fact that you can then use to replicate your configuration. I like to start with an answers file, so I generate one rather than having packstack just go off and do stuff. Then I can edit the file. It gives me something that I can stick into version control and diff it against other configurations and perform other useful tasks with. So here we generate the answers file using whatever packstack sets up for the defaults. Now for this architecture, we're going to make a few changes to that file to make everything work. It's not a lot of changes, surprisingly, to get from the default kind of single system installation to a multi-node installation. Just stepping through each of these here. The first one, I'm disabling the Ceilometer install, not because I do not like Ceilometer, but because with the current version of packstack and the other packages, there is a bug that means that you need to run packstack twice to complete a successful install with Ceilometer. So rather than running it twice during the demo, I'm just going to shut that one off. Ceilometer is the kind of metric metering service for OpenStack, if you're not familiar with it. The Nova Compute Host line tells packstack where to install the compute service and set up hypervisors and things like that. Those are our two nodes there. These may or may not actually match the IPs in use today because this is a new environment I deployed for this morning's demo, but they'll be similar. Then we have a bunch of things setting up Neutron, telling it where to install the Neutron services. They're all going on the single host there. It'll be our network controller. We are using GRE tenant networks. That means that tenant networks will be realized through GRE tunnels between the compute hosts and the network controller. The tunnel range is egregiously large for today's demonstration. Tunnel IDs are kind of analogous to VLAN IDs. They help encapsulate traffic from different tenants across the tunnel. And the last setting here I want to talk about for a moment, the OVS tunnel IF setting. When you are using tunneling, packstack needs to know what origin IP address to use on each server to create the tunnel to the network host. The way it does that is you give it the name of an interface, then on each host it looks at that interface and pulls the primary IP address off of that, then it configures that into the Neutron configuration file. This is details of what it does here is that it uses the factor fact IP address underscore whatever the interface name is to do that. All right, and then you run packstack, which looks a little bit like this. And if you are lucky, in a little while, you should end up with the installation completed successfully message. Now, When I say a little while, that can differ. I've got a local package cache here. That means that my install completes realistically maybe 12 to 15 minutes, depending on how fast things are going and whether there were updates I didn't expect. If you are operating straight from the remote repositories, it can take on the order of, I want to say, half hour to 40 minutes, I think I've seen. So if you're doing this on your own, now is a great time to go off and get coffee. Fortunately, we are going to find that it is completed in just a moment. Now let me switch over to a command line window in just a moment. At this point, I'm going to stop showing the slides on this presentation, and we're going to be staring at my terminal window. But most of the commands that I type are going to be in these slides if you want to follow along with those online. Let me just quickly go back here to the first slide, and so you can all see that URL here. This URL down here at the bottom is where you can follow along. That is also linked to from the description on the event and on the YouTube page. So let's just go back here. All right, so let me switch our screen over to the terminal window here. Hello again. There we go. Oh, look, our packstack install has completed right on time. Moving on. So, what just happened? We completed a bunch of system configuration tasks there. There are a bunch of packages installed, lots of configuration set up in etc. Firewall rules, databases created, services started. Let's just take a quick look around here. So this here I am logged onto, whoops, where's my window? There we go. Logged onto the controller host. So if we take a look at what's running now, we can see that there's all kinds of processes running. Most of these here are the Nova controller APIs and whatnot. If we take a look at our IP tables rules here, I'll show this off. We can see the packstack has added a whole bunch of stuff here for each specific service, and it comments them so you know kind of what it's for. These are persisted in etc/sysconfig IP tables, so if you reboot your system, you should still have all the rules in place. If you are installing packstack under Fedora, you may have an unfortunate experience there because the support in packstack for firewall-D is not great yet. So on Fedora systems, you may find out that if you reboot your system, you'll have lost all your firewall rules, and you will either need to set up the system to not use firewall-D and just use the legacy IP table service, or you'll need to take some time to put all those rules into firewall-D rules. And I am not going to do that in today's demonstration, but I'm happy to answer questions about that via email or IRC at some future point. Let's see. Let's go back to my slides for a moment here. Yes, all right, so do the same thing. Let me just log into the network host. We can take a look there and see the same behavior. So let's go over here to the network host. This is where Neutron is running. That's a little bit better. So we see all the Neutron services are started here. Take a look at the firewalls here, and we can see that ports for access to the Neutron APIs are opened here also. And on all of these systems, we've had new users created, such as here with the Neutron user, new users created, and any other system configuration tasks that needed to be completed. So now that we have packstack installed and now we have OpenStack installed and running, there's a bunch of post-install configuration tasks we need to do. So packstack created a credentials file for us here, Keystone RC admin. That gives us access as the admin user to our OpenStack environment. At this point, there's not a lot of resources here. We don't have any machines running. We don't have any networks in Neutron. So we need to create a whole bunch of stuff. Now at this point, I'm basically going to start copying and pasting commands from the slides to make sure that what I'm doing is exactly what I've got in the slides there. See what that thing was over here. So the first thing we might need to do is fix up Horizon. Horizon is the web dashboard. And depending on your install, you may connect to Horizon and find that you get an error message. That can often mean that packstack wasn't able to figure out either the host name or IP address that you're going to be using to connect to Horizon. So let's just take a quick look here in etc OpenStack dashboard. We're going to look at the local settings file. Now look at this line here. I fixed that as part of a post-install script earlier. I apologize. Normally, what this would be is a series of IP addresses and host names. Now, because I'm running this OpenStack environment inside a virtual environment where my external access is actually coming through a NAT rule, packstack wasn't able to figure out what my IP address was, or what IP address I would be using externally to access this. So replacing this with a star means accept anything. From a security perspective, you don't necessarily want to do this. You want to have this set to, like this example here above it, the host name or IP address that you will be using or you expect your users to be using to connect to the packstack environment. Let's get out of here. Now we want to do a bunch of things, starting with provisioning some images into OpenStack so that we can use those to boot images. We are going to start with the Ceros image. So here's our glance command to actually pull that down from the Ceros website and install that. If you're not familiar with it, the Ceros image is a minimal image designed to be really good for testing cloud environments. It's very small, so it downloads quickly. It doesn't have a lot of features, but it's got enough to let you log in, verify that you've got functioning networking, attach volumes and stuff to it, see that they work. So it's a great way to demo stuff. So that should be available to us now. It should show up as active. Yes, excellent. Now we need to create some networking here. The first thing we need to do is set up an external network for our instances. So what we've done here, neutron net create external router external equals true. This says I'm creating a network named external, and I am telling OpenStack that this is my external network. I need to create a subnet on that network. I'm going to do that right here. We're creating a IP range 172.16.13.0/24, and we're telling it to disable DHCP because this is the floating address range, which are not assigned through DHCP to instances, but are assigned. They are assigned as NAT rules on the router. We'll look at that in more detail in a moment. All right. Now we have our subnet. Now we're going to create a new flavor for doing our testing. Because this is kind of a resource-constrained environment. If you look at a lot of the existing flavors here in Nova, there we go, they start out at 512 megs of memory and go up from there. I'm going to create a new one that uses 128 megs so that I'm able to create a couple instances and not worry about resource constraints during the demonstration. So there we go. That's all set. Now we are going to create a non-administrative user that we're going to use for the rest of this demonstration. So we're going to create a tenant named demo, and then we're going to create a user named demo and stick them in there. So there we go. That is all set. So if we can, at this point, run keystone user list, we see that our demo user is right there. All right. So we're going to create a credentials file for that user, just like we have our, wrong directory. Just like we have our Keystone RC admin for the admin user, we're going to create one called Keystone RC demo. Oops, didn't want to do it that way. I wanted to do it this way. And I may need to update that auth URL. Let us just verify that that is the same. Nope, that looks good. So at this point, we're going to become the demo user. And we should find that there's some things we can no longer do probably. Yes, excellent. So now we are the demo user. Cool. Everything from this point on is not as admin. So we need to create some networks for this user here. Let me find my commands here. There we go. We're going to create a private network called net0, not terribly imaginative, and we're going to create a subnet on that network. We're going to use the 10.0/24 range for our private network. Now you'll notice here I have set the DNS name server to 8.8.8.8. That's one of Google's public DNS servers. If you don't set that, if you don't explicitly set a DNS name server, you will probably get one that's not terribly useful. More typically, you'd be setting something inside your organization. Here, I'm just using the public one because that's something that should work anywhere you are setting this up. All right. Let's see here. we need to create a virtual router, which is going to connect our tenant networks to the external network we created earlier. So we create a router. It's going to be called ext router, not terribly imaginative. We are going to tell the router to use our external network for external connectivity via the router gateway set command here. And we are going to connect the router to the private subnet that we just created. There. Now, you'll notice earlier, let me just back up here. When we created that subnet, we gave it a name. That's useful because then we can refer to it by name later on. If we had not done that, then we just have to use the UUID instead, which just means running subnet list a lot to get your UUIDs. All right, so now we should have, that's not how you spell neutron. Now we should have a couple networks visible to us, the external one and the internal one. There we go. Great. Now at this point, we need to create some security groups to make sure that we allow the kind of traffic that we expect to use. Here we're going to allow ICMP and SSH traffic into our instances. So we're going to modify the default security group rule, first to allow just ICMP traffic, and then another rule to allow TCP traffic on port 22, which is SSH. All right. Now, last thing we're going to do before booting an instance is create an SSH key for this demo user that we will use for logging into things. Let me just find my slide on that here. All right, so anyway, going to SSH keygen. Create a file called, we'll call it demo RSA. It's an RSA key, 248 bits. We're not going to have a password for this one here. All right, we're going to send that to Nova via the key pair add command. Oops. Yeah, there it is. Nova key pair add -- pub key. That. I'll call this one demo. Whoops, it's not pub key, it's pub - key. All right, and we can see that here with the key pair list command that's been loaded in. Awesome, so now we are ready to boot an instance. We have a network, we have an image, we have security group rules, so let's go and boot something up. So we're going to use the nova boot command here, and we're going to use the -- pull flag to it, which means this command will wait for the image to finish booting up before it returns to us. We need to specify, we need to go back for a moment. We need to get the UUID of our internal network. There it is. We need this one here. So we need nova boot -- pull -- flavor, whoops, this hero's image. We're going to specify a NIC by network ID, like that. And we're going to use our demo SSH key for access. And we're going to name the system test0. And then we are going to wait a short bit. And that should go pretty quickly there. All right, well, while that is booting here, we're going to note that once the system is up, we won't have any direct means of access to this server. It's on a private network, which means there is no route connecting that to either our controller, our network host, or the compute hosts. It's still possible to get to it. Let me bring up another window here for just a second, because we're going to explore. Let me swap here. Let's see. Hello again. Screen sharing, there we go, this one here. And so this window, we're going to go over here to our network controller and just take a quick glance here. So we have a couple of namespaces on this hosts. Namespaces are a way of isolating sets of network interfaces, firewall rules, routing, and things like that so that they do not interfere with each other, to provide kind of dedicated virtual networks to the tenants and things like that. The two namespaces here are associated with the virtual router that you created, that is the qrouter command, and the other one is with the DHCP service associated with our internal network. From either one of those, we could use the ipnetness exec command to run commands inside that namespace. So here, for example, we can run the IP address command and see that there is an interface there with an IP on our internal network. Now, in the other window that you folks can't see right now, I can see that that server has finished booting up, and it is at 10.0.0.2. So if I were to try to ping that from here, the system doesn't know how to get to it. There's no route. But if I run that command inside my namespace, I can ping it. And also, from here, I could log in at 10.0.0.2. Except the system hasn't actually finished starting up SSH yet. So we'll give that a second. Yeah, we'll give that a moment to boot. And I'm going to switch back to the window where we're looking at the controller, because we're going to do a couple additional steps there. No, still booting up. Switching back here to the controller. I think that's this one. Yes, excellent. So now we see that our server has booted, but we don't have any external access to it yet. We're going to give it a floating IP address. So the first thing we need to do is a floating IP create external. This asks Neutron through Nova to create an external IP address on that external address pool. And now we are going to assign that to our system over here. So Nova add floating IP, the system name, and the IP address. Now, in an ideal world, we would be all set at this point. But there are actually a few steps that we need to take here, because there are some things that packstack doesn't set up for you. So let me switch back over to our network host. And I realize there's lots of switching going on here. That's all right. So here's where we are again. I want to show at this point that that instance has finished booting, so we could actually do this trick of logging in through the namespace there without the external IP address. And we can log in there. Yay, there we are, we're logged in. But that's not what we're here for. In an ideal world, now that we've assigned that IP address, we would be able to connect to that from here without any trickery. It's not working right now. The reason is, and we're going to go back to the slides for just a moment, that packstack does not finish setting up external connectivity for you, because in a deployment that's not just a demo like mine, there's usually some manual configuration involved to make that happen. So let's just bring this up here. Go back to this slide for a moment. There. In the real world, you would have your Neutron router connected to an interface on your system called RHEL, and we'll see that in a moment. And then you would have probably a physical interface also attached to that bridge that itself is connected to a physical network with a real router on it, giving you internet connectivity. Now, for today's demonstration, we don't have that, so we're going to do a little bit of trickery here. We're going to set this default gateway IP directly on our bridge interface, and that will give us connectivity into the OpenStack environment. And then we're going to set up a masquerade rule in IP tables that will give our systems outbound access. So let's go and do that right now. There's my screen sharing again. So let's just set up something here. We're going to split this window for a moment. And here we're going to run that ping 13.3, and it's failing there. Great. So we're going to add that IP address onto RHEL. Fabulous. Now you can see it is pingable. So if that IP address was a real router somewhere external to our system, you'd now be able to get into it. I'm going to log into that server anyway here. Let's see here, suros at 172.16.13.3 using the suros default password. All right, so from here, you would expect that I would be able to do something like this. We can't yet, because we don't have our masquerade rule that we need. And again, these are only really necessary for this demonstration. In a real world, you'd be using an actual router. And now if I were to come back down here to this, now we have working outbound connectivity. So that is pretty much what we hope to accomplish. We have a system with 4 nodes in it that we're able to boot instances on. They have successful outbound connectivity. We're able to get into them without needing any namespace trickery at this point. In a real deployment, they'd have functional inbound connectivity also. We have a non-privileged user who is able to create networks, connect them to the external network, and otherwise create complicated kind of virtual environments. So we've pretty much finished up what we started to. At this point, we seem to have been about exactly half an hour, which is what I was hoping. And I would like to open the floor for questions on IRC, or for me directly, or whatever people have in mind. So let me just mention IRC here. All right. There's a lag of probably, let me see if I can tell on the screen here. There's a lag of a couple minutes on the live stream, so some folks may be finishing up watching right now. But if you are on IRC, I hope that if you have questions, you feel free to ask them right now, even if you're in the middle of watching the presentation. And if not, I hope that it was at least informative. So I'm just going to hang out here for a little bit. I know some folks I was talking with earlier on IRC had some questions that I hope were answered by today's demonstration. Let's see if there's some comments on that. So Rich Bowen is asking, when will packstack and Neutron do all this stuff for you by default? I guess I would start by saying that this is not something that Neutron should do for you. I think that packstack should have an option for simple environments of setting up connectivity to an external router. And I know that there's some commentary on the RDO website that somebody is working on that. I don't know the state of that right now. The slides are, I hope, somewhere convenient already. And they have all the command lines that I used in this demonstration. Sorry, I'm talking and typing at the same time, and that may make me a little bit confused. So let's see here. KitP is asking, what was the config option to specify the bridge to a network interface? If I understand the question correctly, let's see here. Let me ask for details on that, KitP. So I'm asking for some details on that question to make sure that I'm answering the right thing. Maybe if I just switch over to let's see, GMI asks if I can provide a copy of the answers file that I used. Absolutely. What I will do is stick it in the repository that has the sources for the slides also. So I will stick a link to that into the slides and update that in just a moment. All right. Okay, so KitP was asking about the option to specify the bridge to a network interface, and has found, I think, the answer that he was looking for, the config Newton OVS tunnel IF. And yes, as Rich Bowen says, the slide presentation that is linked to in the description to this event has all of the command lines that I was using during the demonstration. In fact, I was generally just cutting and pasting things from there to make sure that what I was actually showing on the terminal was exactly what's in the slides. All right, if there aren't a lot more questions here, what I'm going to do is turn off this broadcast pretty soon, I think. Let's see, Beav is asking if you were to use Icehouse instead of Havana, would the steps be mostly the same? The answer there is yes, they should be very similar. They should be very similar. Most of the packages are going to behave the same way in Icehouse as for Havana. I don't think, off the top of my head, that there are any substantial changes that you need to worry about there. Had I not started with the Havana packages when I started putting together this presentation, I probably could have done the same thing just using the Icehouse repositories. All right, I'm going to turn off this broadcast. I hope that you had a good time. I'm still hanging out on IRC if you want to ask any additional questions. And you will generally find me there, business hours Eastern time, if you have questions. I'm usually happy to answer them. Thanks.